Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting tech applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been privy to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And this week we're gonna continue down our, I guess you can call it now at this point, a rabbit hole. Rabbit hole, obsession, journey. The book of life when it comes down to 3D printing. And, this week we're kind of going to go down the safety rabbit hole, because, 3D printers are one thing that are, there's a lot there that can hurt you. It can hurt you fast, too, if you're not careful. And it can also, reduce your mortgage payment pretty quickly. If you own a house and next note, the dang thing's burning down. So
You got plowed land.
Yeah, exactly.
Burn rubble.
You can go from home to land in no time flat. But, so, with that, I guess we can, kind of get started. So everyone to hear us run our mouth about something, something absolutely insane. Yeah. John, what do you think about when you're the one here who has the most experience when it comes down to, 3D printers.
So,
what do you think?
I could start on the hobbyist side because I think that's probably where most people their entry point's going to be at.
I'd hope so. If you're not buying a $12,000 professional printer for your first one.
There's some of us that go just right into the Prusa and buy multiple, and they're like, I'm ready to go. But if you're just buying an Ender or buying some another brand, Anycubic, whatever it may be, you're just getting a small printer. You're curious. If it's an FDM printer, you're going to notice something real quick. It's going to radiate some heat. Yeah, because the whole goal is to heat this plastic up to change its form. So you're heating up the hot end to 200 degrees Celsius plus, and you're heating the bed to minimum 60 degrees Celsius plus. And I know that we usually talk about Fahrenheit. It's getting
freedom
close
units.
to freedom units. It's getting close to like 400 degrees Fahrenheit on the hot end. So you touch that thing, you will know not to touch it again.
Instant.
Hot end.
Instant third degree burns.
And I'm going to be honest, I have some finger burns of where I've touched the hot end where I was thinking I need to clean it. Like there are certain things with the quality and the maintenance of a nozzle of if I have let's say a print fail and or the extruder fail and it's not pulling more filament in, that heat's got to go somewhere. So it's going to continue to heat up whatever remaining filament or excess filament's there, and that builds carbon, and it kind of crusts over. And your next print, or whatever filament you're going to use again, is just going to have it. You're never going to be able to have any quality or any good print. You're going to start noticing more like over extrusion.
Yeah, degradation.
Yeah, but so there's things like that you need to maintain. And what I was doing was I was just cleaning the piece off. In reality, I probably should have used a metal brush. It might have been a little bit easier. I just had a piece of jean.
Yeah.
I mean, it's just what I had around. Wiping it off the jean. I was at the end of it. Grabbed the nozzle. Immediately let go, but 2 seconds does a lot, or half second does a lot of damage still. Yeah. I've never touched it again.
About to say, what did we learn?
But it's safety. But you go into that, and yes, that was a small situation, but you talked about it already, burning your house down. Fire suppression is a thing where you're heating these things, and if that heat, like let's say you ran out of filament, and this is a 15-hour print, or God forbid, 3 day print, and you were out for the weekend, and you hit play before you left, and you wanted to monitor it. This is why having any type of monitoring while you're away from home is important, because if that heat doesn't go anywhere, that printer's like, all right, I'm good to go. It's going to keep heating.
Yeah.
Catches anything flammable.
Yeah.
Anything.
Or if you have a cat that just magically knocks it over.
Yeah, listen, I found my cat chewing on the filament before. That's why I keep the door closed now, and that's why it's got an enclosure, because anything that could like jump into that environment could ruin not only the printer, but everything around that printer. Like, God forbid you're paying you're gonna have to get a new house, a $200,000 house. If you just lost like a $200 printer, you just lost that caught fire. So like I think that.
But your Batman symbol was worth it, though.
Well, yeah, some things will survive, but yeah, the printer will still be sitting there afterwards. But
right.
but yeah, if you're thinking about a maintenance safety too thing, I think it's also something like we talk about light shields and things.
Your light curtains. I was actually going to bring that up.
Yeah, so like on a maintenance standpoint, I'm thinking about those sensors. But like, what do you think about, Ed? Like,
Well, I would say that the biggest thing is you have electric water heaters and they run all the time. Mm-hmm. It's about having the right things in place with those type of devices. So if you're doing a 3D print, another thing you want to look at is the filament itself. You know, some filaments are more hazardous than others. So like if you're using carbon fiber, you do not want to breathe in those fibers. Mm-hmm. If you're using, like PLA, even PLA, you don't want to breathe in those fumes.
Yeah, because of gases.
But you want the right PPE. No. You want to wear leather gloves. Mm-hmm. You want to wear a face shield if you're doing something where you think that you're taking the nozzle off in some hot molten plastic splashes. Or the other thing you want to do is you want to wear a respirator if you're going to be in that area that's enclosed. Or make sure it's well ventilated. I would say those are things that you definitely should pay attention to. And then, as far as when you're saying like touching things that are hot, just wait for it to cool down.
Yeah. Well, now with that, I'm gonna kind of propose this question. You and me both are used to industrial controls at various levels, across different things. Like John brought up light curtains. Now you have guys who are running the enclosures, not just to maintain temp and maintain, some sort of controlled chaos, but also to prevent kids from reaching their hands in there and grabbing onto something. If you're going to use one of these things in the classroom, for the love of God, use an enclosure. Yeah. However, also use a safety relay that knows when that door is open and closed. So it immediately stops the print bed. Stops the print bed, stops the extruder, and lets it rip. Right. So, where I'm going with this, and we'll probably go down a pretty good rabbit hole here in a minute, is what if somebody out there on the hobbyist level figured out how to make or use industrial light curtains and outside the frame of view. So if you're talking left and right lateral limits, and also, in front of it, if you build a platform to do, a 360 light curtain around. Once you break that light curtain, automatically throws an e-stop. It shuts the print bed down, drops all the way down to zero, and starts cooling off the hot end immediately.
Well, they won't necessarily drop to zero.
It would start to drop.
You would want to latch it. Like you could use the curtains, but you still would want to latch the door. So
right.
The door,
but I mean, if you
can't be open until that temperature is reached.
But now, what I was thinking is this: if you don't have a enclosure of some sort, a light curtain's your next best bet. That as soon as you break that light curtain, you're stopping that print bed immediately. It's throwing that relay.
So that will work.
It's not 100% safe, but it's an idea.
No. The light curtain part is safe.
Yeah,
it's nothing. What you're talking about is perfectly fine.
Yeah.
The only issue, because we don't want people to have a false sense of security, is that nothing is going to cool down to zero that quick.
Yeah, and if you think about it,
unless you blast, fans on and say, hey, the fans stay blasting to cool it down, and then it takes
water cooling, even
whatever, something like that.
Then that's another thing. Why not use your extruder fan?
Yeah, that's what I'm saying.
And have it out feeding down to the bottom. Once that's tripped, it kicks on another fan, another relay that sets up fans up underneath the bed and start cooling up off everything up underneath.
And you can't fix everything.
Right, exactly. You can't the whole thing is you can't fix stupid. You can't fix that. However, the thing is you can't fix the greatest thing in the world, which is wandering kids. They just want to learn. They're curious of what things are. You have friends and family out there who, may have kids that have, auditory and sensory issues, and they want to be, touchy feely. They want to see that things because they're interested in it. They want to learn it.
Yeah,
it's not because they're trying to make it cause an issue. By any stretch of the imagination, they just want to learn. And for me, that's why my big thing is safety, especially if we want to use and get these things into the hands of people who are in the classrooms. And I think that if we start treating a 3D printer like a robot cell, for example, especially in in a classroom environment, once we can get rid of that one extra level of problems, I think we've gone on to something. If you can just dismount, say, the control box outside of the cell area, the filament outside the print area or the cell area, and then inside that cell we have built up a 3D printer that sits inside of a cage,
And just
because I think they should be held to the same. Now, I'm gonna. I hate to go down this hole because I know you're thinking on something, but why are we not treating? And I'll let you grab this one. Why are we not treating I'm not treating the 3D printers with the same safety standards that we treat robots with? When it also comes down to fencing and stuff like that, where fencing can only be so big.
Because the reason you do robots is because it's the stop distance of the robot is in motion.
Right.
So even with a 3D printer, even if it's moving at whatever speed, you can pretty much stop any 3D printer with your hand.
Yeah.
The torque of a typical step motor can be cause to torque out or cause the overcurrent because you got more force than that motor. But what I was going to say is you don't have to have industrial light curtains.
Right.
You don't even have to have the things you're talking about with an enclosure around the whole box. You can still do everything you're talking about because we have that technology with the garage door openers.
Yep.
And it doesn't have to be the same. The reason it has to be as safe as it is in an industrial environment because things are moving.
Right.
And then the light curtain is supposed to protect the person because they can't. Once a robot is in motion, you cannot stop that robot, because it's going to decelerate at a certain time. So I think what you're talking about is yes, the concept that's in industrial environment, but made into a hobbyist commercial. Yeah. So open source. We need open source devices like you're talking about put into the hands of the hobbyist community to add these items to these 3D printers.
Like proximity sensors, like you're saying with your garage, or like light curtains. I think a light curtain is a good idea because it's easy enough for the hobbyist to kind of get to wrap his head around and kind of set up early on in maybe your 3D printing career. Honestly, when you brought up or when you're kind of pushing this thought process, I had an idea and it kind of revolves around that. What was it, that hangbot that we saw, where it's like, why do I need to wait for the manufacturer to pick my build plate size? Why can't I print as big as my room or print as big as this block? Or that's how the housing and the cement housings are getting built is because they just said, why not make it bigger? And in that sense is, they have the structure, but the hangbot you can hang in the corner of your rooms, and it uses like a Delta printer. It uses those pulley systems and things like that to print on whatever bed size that you want. And if you create that light curtain or that safety field around it, then you've not only created a safe environment, but you've also created your build plate. It's it's still early access, it's open source.
But that's the perfect environment.
But that's the environment that immediately I thought about.
Across a room. But if I'm saying what we're talking about in a classroom.
Yeah, that's fair.
To get these devices from hobbyists to a classroom,
right?
For whatever program it's going to be, whether it's engineering at a college level, whether it's at a junior high or a high school,
so inside the STEM classroom,
or grade school, you have to keep it affordable.
Right.
So what I'm saying is the technology exists in that big enclosure that's industrial because it's in a hazardous environment.
Right.
So you're paying more for that. So that's why I said those things need to be open source so we can miniaturize them, just like we miniaturized the original 3D printer for hobbyists. Yeah. We should miniaturize those things so it's affordable, and you still getting the light curtain.
Right.
You just making the light curtain on a level that works for a hobbyist in a school.
Yeah.
Right. I kind of want to take a second, and if you guys are okay with it, pivot, because we talked about improvement quite a bit, and like upgrades and stuff like that. And at the end goal is like, do you want to make everything out of plastic? Sometimes I need a metal part. Sometimes it has to be a metal part because of how much stress it needs to endure. But when you get into metal 3D printing, the levels of like safety to me, like it gets so much closer to industry. Like it's wild to me how dangerous this stuff actually can be. But then researching like things like laser powder bed fusion, which they're just throwing out powder and literally welding it to the print bed and then doing it again and welding it to that layer and so forth. Like those things are happening right now, and that also, like, you have the threat of inhaling like metals, but there's also FDM. Like, they're pretty expensive, but there's FDM materials that emit the same type of
VOCs.
Like like you don't, like formaldehyde and things like that. You don't want to inhale any of that. So I think if not a light curtain, please in the enclosure.
The enclosure should happen.
Yeah, I think that's probably one of your first steps, because now, like resin ones already come in the enclosure.
And the thing is like what you were saying earlier. You know, the conversation that you and John had earlier about the enclosures putting a reverse flow air filter on there that sucks it through friggin', carbon, or a charcoal filter, and kills off all those VOCs, so you don't actually have to worry about it. It's it's one thing. It's playing with the right things. If you think about it, I was doing some research the other day, and and the thing is like relativity space, and I keep hearing them up, but right now they're the guys who are on the bleeding edge of what 3D printing is. They're at the Terran 1 rocket that's now down at Kennedy Space Center that they are going to light the fires on and kick the tires and kind of see what happens. See if this thing can survive. And with them, they use a KUKA robotics arm, with a weld head 3D printer on the end of it. And it's something that you kind of see. But I was doing some research into them, and their ventilation system inside their areas are freaking absolutely insane. They have these robots set up where humans can be working with them, through their entire life cycle, because they're not turned up to a high level torque on them, so they're not running at a high rate of speed on certain things. Like once the humans are out of the cell, they trigger the cell and it speeds back up again. But I guess it's all based off the turntable to what some of their videos are showing. But the thing is I think that right there is what the splitting edge of what the marriage of 3D printing and robotics are in a safe, workable, together environment. You're not talking about like a pick and place robot or a helping hand robot, that would help us pull boxes off shelves and stuff like that in the manufacturing environment. Like the ones I guess KUKA has on the back of their AGVs. Those. Yeah. But we don't have those yet. But I think that's kind of where people want to go, eventually, is at that level.
Yeah, like I said, the big thing is, like I said, well, the reason that 3D printing is taking off in the hobbyist platform, or on the hobbyist platform, is because they took and made it affordable. Yeah. They miniaturized it and made it affordable. Mm-hmm. The reason we're starting to see it more in education is because it is a good tool for teaching, right? And it's affordable, because some of the things that you would need to model would be very expensive for somebody to make, right? And so I think with anything we say in safety, I mean, the main thing I would do is you could do two things. I can make the 3D printer just like the microwave. So as long as the door is closed, I operate. As soon as the door is open, I don't operate. Once the door is open on the 3D printer, I blast however much air I need to blast to cool it down in whatever seconds. Mm-hmm. That would be an option. The light curtains would be good because, like I said, but open source light curtains that the hobbyists can get a hold to. and make it affordable for a school environment. Because even a small, say like a small 6-inch or 12-inch light curtain, it's like $200-300 for one.
Yeah.
And you got to have a receiver and a transmitter, or you got to have a receiver and some reflector to, and they're a little bit complicated.
Yeah.
It's not just a plug and play thing. So that's why I say I think that technology is something that's where we're failing as a manufacturing environment, where we're not giving some of these things back to be open source. Mm-hmm. You don't have to give away trade secrets, but you can give people basic kits or sell evaluation kits that people can use to learn the thing. Just like with microcontrollers and people that get evaluation boards, you should do those type of things.
Yeah,
I think then those things are perfectly. You're right. And then as far as the enclosure, like it doesn't have to be like the enclosure that we think of on an industrial floor. Mm-hmm. It could just be that we have some 80/20, some plexiglass, and then if you get into that little area where the plexiglass, it cuts out. So we just have to miniaturize what you're saying, industrial, to the school environment. We just have to make it open source.
And just think, right now there's an abundance of plexiglass.
Yeah.
Look, we just had COVID. Okay. We got plexiglass coming out the ears.
Yep.
We got desk separators coming out the ears. Yep. We got plenty to deal with. Okay.
I mean, getting down to it too, like, because on a hobbyist level, you're trying to, of course, you said it before, trying to make it cheaper, but there are a few things that you could do that would possibly eliminate a lot of needing to add. I know we want to add tech, and I'm not advocating against not having something or a sensor on there.
The best tech is low level.
Yeah, for me, I think you need something monitoring a lot of things, and I think that you need to, even just having a camera just to look-see is enough. Even MQTT, that's kind of saying, hey, drop below my temperature, you should probably take a peek. Yeah. Or I'm above temperature, you should probably look at it, it might be on fire. Things like that are in some cases enough, but also my brother's done it before, where he hated the enclosure because there on the ender, if you don't have your auto leveling yet, there are knobs on the bottom that you need to reach. There's there's 4 of them, so you got to go around the right corner and the back side, around the left corner, back side. If you're messing with anything on the chipset, you got to flip the thing upside down and things like that. Now, if you're leveling the bed while you're doing your first layer print, it's going to be hot and in motion. So you can't really, an enclosure you get a couple end tables and stack them. IKEA lack tables are a big thing on Thingiverse for you to build off of, and honestly, I've built one myself like that, and it's perfectly shaped. It is a pain to get to any of those leveling things, which is also why I got my auto leveler. That, in that sense, I can understand it makes it harder for you to be a little bit safer. But also, there are still ways that you can have an enclosure. Creality actually has a type of tenting system which does that. You could put the printer in a side closet instead of a main room. Maybe not putting it out on display so that your pets can see it or know what's going on. They'll probably be questioning the buzzing going on in the closet. But who's this at? You got a camera in there, maybe a little LED light, and you can take a peek at it every once in a while. You don't need that's more of a closed system, I would say.
Than in the garage away from flammables. Yeah.
Shoot in the shed in the back if it's got power and maybe hopefully internet if I'm doing Raspberry Pi Octoprint. But I so much can be said for don't keep it in the environment that you are kind of just living in, period. It may be cool, don't do that. It's just an accident waiting to happen is what I'm saying. So those small things, like getting it away from you, putting it in another room that nobody's going to get to, or maybe even locking that door to the garage if it's in the garage, those are simple steps you could probably take. And then these light curtains or anything, sensors, proximity alerts, and blah blah blah, that can be added afterwards, and I think should be added afterwards, because if you get onto a bigger plane, you can put even the light curtain on the build plate, and then it can, if you have spaghettiing, that'll detect your spaghettiing. So it can help you on the quality.
Mini 6 scanners.
On all these things. Yeah. honestly. So
like I said, well, the big thing with the leveling, from what I'm seeing, like I said, I'm just now getting into it, but I think a lot of that is because when they originally made the design for the Ender, that was at the time their best way of doing it. You don't have to do that anymore. In my opinion, I think even the people that are using the sensors, and somebody's gonna get upset, you're doing it wrong, because it should be the same way. Just like I have a phone, and I can take that phone and level things with my phone. Before I cut on anything with temperature, I should verify the bed before I go poke points. The poke points is for the Z. It's for the Z axis. That's for when we come down with the hot end. We're verifying the hot end. That's what we're afraid of, is we're going to crash. Or that we're going to have a print that's going to be unlevel and so forth. But in my opinion, the leveling should be separate on the bed from the leveling that's on the Z axis or the print head. Because for me, I think I would rather have an XY system and get rid of the Y, at the bottom, and I would rather raise the plate, raise the bed all the way up to the top and go down. Because I think down is going to stay more level than trying to raise something up.
If you think about it, you could probably level with just like as a sensor. You think about it, you can hook up a acoustic sensor. That'll read, or a ledger sensor that'll read your measurements from each corner.
I'll do you one better. They make a tilt sensor.
Yeah,
there's an actual tilt sensor that when it's not level, it doesn't make.
Right.
No.
And it's when I say it's cheaper than the sensor you're talking about, and it's more accurate. The reason it's more accurate because it's physical. It physically is on the bed. Now it doesn't have to physically be on the plate where you're heating. It's physically on some part.
Yeah.
That's raising.
Yeah.
And then you can do that, or you can even do stress sensors to see if I'm getting out of getting wonky or whatever.
Yeah.
But even all of those ideas are good. It doesn't mean that one is better than the other.
Right.
I just know physical is always better than logical.
Yeah, because the standard now is the BO touch. The BO touch is just a probe that goes down,
Yep.
touches, hits a certain point, pops back up, sends an alert. It's like, oh, too close. This is my 0.
Yep.
This is the end. It does that 16 points on your bed. So this is it. It'll, even if you have gyres, which is a special firmware, will pop up and tell you you're low here on the right side, right corner. You're high here on the front left corner, and then it'll help you. Or you can just change the Z offset and say, hey, I understand that I am this close. Let me offset it so I can be a little bit better. And that usually happens when you're doing your first layer print. So in that sense, I don't think I've actually touched those knobs in maybe 6 months plus, maybe even closer to a year.
See, I wouldn't even have the knobs.
Yeah.
To me, the system I'm talking about, and like I said, I'm a new guy that know technology from the industrial side. You would set the bed, because basically I would have one rail that's on a slide, and I would have 2 lead screws that would be so I'm level here. Also, you would have, the way that would work, you would have guides also to make sure that you couldn't get. But here's the reason why you don't need those knobs anymore, because I don't care about tweaking the knobs this way, because that was when I was going this way in the Y direction. If I make X and Y dependent on each other, and if I raise the bed to the top and verify that the bed has its own leveling system, and the Z axis has its own leveling system. The Z is so quality and don't crash, and then of course the bed is so that, okay, hey, I'm at a known 0 for quality. So I think in that, because what I've seen on some of the industrial printers, I have seen none of those adjust anything on that bed that way.
Yeah.
With the knobs. I'm saying knobs related, not.
Yeah. I think part of the Ender when it comes like stock is that those screws are attached to the bed. So that's part of like the knob problem, and it becomes more of a stability because you don't want it to wobble because they're not really actually attached. They're just kind of like taped on with that little thing. It's not very great, but that's why I have like nylon locking nuts that I locked it close to the bed, and it stabilizes the things. I agree. I don't think you need the knobs.
Well, hobbyist version of Ender that we have now, you do. I'm saying if you had a different style bed that didn't have
just a couple upgrades though.
Yeah. So say if I had a different style bed. Say if my heat plate was 2 foot by 2 foot. Yeah. So now it's not DC. Of course, it's AC. Of course, there's some other problems with that. You got to use solid state relays. You got to use thermal fuses and things like that to make sure that you don't run into issues with fire. Yeah. But what that does is now I don't have to have this. I can mount the plate a different way. So what I'm saying is maybe the problem is the way we mounted it with the Ender is what we had to do at that time. That design of printer to be affordable. You look at the Prusa, I think it's a little bit different.
And now, if you think about it, if we're getting on, how upgrades can like improve safety and stuff like that. Really, what you're getting at also is the fact that if you start dealing with like machine learning, and I know we're getting close to going. We've actually gone over time here a little bit, but whatever. Is if you use like machine learning or vision systems. Right now we have the ability to get vision systems for a 3D printer. I showed John one yesterday in Docker, and sent him on a wild ride. So you learn one thing to fix the other. But the thing is why can't we set that vision system that if it detects something it does not like, that is not supposed to be there, it stops immediately. We already have the anti-spaghetti monster. Yeah, why can't, if you see a hand come into that spectacle, shut it down immediately. Yep. And like if you are using a wider enclosure so you can do your auto leveling and stuff like that, as soon as that a hand enters that enclosure, shuts that down, it takes your exhaust fan and reverses polarity and pumps air back into it. Or you just have another fan at the top and you only turn that on when the power goes out. Yeah. Or when the door is open, that fan kicks on. You use a high CFM fan, and it cools everything down based on machine learning.
That's exactly to do what you're talking about with the.
Or not machine learning, but vision systems.
The open source light curtains, the open source like 6 sensors that basically are light curtains with a mirror. Yeah. That's floating around. It makes a scan feel. So you still can do the thing, but those things need to be open source so they can be miniaturized. Yeah. And also, they don't have to be industrial. They don't have to be ruggedized for an industrial.
You can use the vision system that you can get for a Raspberry Pi. Hook it up to a Pi Zero or Pi one of the Pi Zero real quick, and have it and lock it with a set of lock screws at the top of a printer. Yep. As soon as it knows it's something outside its ordinary method of operation, it throws you a fault.
Well, yeah, we talk about even it throwing faults. Like it could still and why can't it have readings too? Like the Bamboo X1 that we were looking at is it lays down a couple lines and it does flow rate testing on with LiDAR. Like why not? Like why can't it be a sensor for safety and also a sensor for quality?
Yeah. And the same thing is like the LiDAR thing is great if you're talking about using vision systems, because LiDAR is a next generation vision system at that point. It's not just black and white, take a picture. Like it is in some, industrial applications, which still doesn't make any sense to me. But, cheapness, I guess. But, the thing is, if you have both of those on the same printer, you have one measuring one, thing and one measuring something else, and they're also on 2 different wavelengths. Yeah. So, you have, that entire freaking thing covered, and you may have spent $45. Maybe $45 if you went through the Raspberry Pi website and bought them from them. Yep. Or you went somewhere and you got a weird deal on Amazon. It's just one of those things. But that's here nor there. Maybe something down the way, we can play with, build something out and just do a quick test on it. Yeah. And I don't know, none of us want to get, roasted, but it's one thing that, if we can help, benefit the community and the greater good, You know, we're not going to put ourselves intentionally into harm's way.
I'll sacrifice a couple fingers.
Yeah, maybe a few extra scars.
I've got a lot of them.
You know, scars are just everlasting memories. But to be able to benefit the greater good, something that will help. Maybe if we can help get this out there, we'll get 3D printers in the classroom faster. Yeah. It will take the method of the madness of pushing STEM, pushing education, pushing the fact that we all talk about technology all the time, and the big thing that we really wanted to get out of all of this is make it like a lunch and learn. And the thing is that's going to go to the channel too. It's like a lunch and learn. Come take a look, see what we're doing. Because if you never stop learning, it's just one of those things. That's what we kind of look for. So we've definitely gone over time. So I'm going to turn it over to the guys, and we're going to go ahead and end it here. So y'all go ahead and take it away.
So I just want to circle back real quick. On two things. First, I'd like to thank you guys for listening to us. The other two topics that I want to talk about, so we was talking about access. So maybe the problem with access to some of the things and what we have, the people have existing equipment that they just, you've already paid money for it. You don't want to change all these things. But maybe that it's a better idea to take and move all the electronics from the bottom to the top, where it's easy to access it.
No.
Maybe when we start talking about having to do something with making an adjustment on the bed, you add some extensions so that you can get your hands in there and have access.
Like a 3D printer storage, 3D printer server rack.
So stilts, stilts for a 3D printer so that you raise it, you make something where you can raise it, and I can get my hands under here. It's in the enclosure. I can open the door, put my hands in, and make adjustments. And then I would say that the other thing that I would also say is when it comes to the safety of the 3D printers, then you need to make sure that you teach. You need to take the kids to the printer, show them, hey, this is hot, don't touch this. This will not cool, and you can do it take a hot dog. Take a hot dog with it, with it hot, and say, you hear that sound? That's your skin.
It's a piece of paper.
Yeah, so those are some things that you could try, and we'll let John close us out for today.
Yeah, so there was something that Nick said earlier that it made me laugh because it reminds me of a quote that I found very early on in 3D printing. You can't fix stupid, but you can fix what stupid does. And most of the time, that's what I've been doing with 3D printing, is because something stupid happened and I'm trying to fix what it's doing, or something was like not machined the correct way or not put together the right way. The main point I'm trying to get is that you should question everything that you've kind of see in structure. Like if it's a system that's already set and sold to you as a package and has been sold that way for years, you should question why that is so efficient and why no one has innovated with that. And it could be you that does the innovation. So I'm just saying, combine some technology, combine cool things that you've heard, and you'll come out with a nice product. So try to learn something new.
I guess. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.